So we're going to look at those transformations in the Desmos program. So here I am in Desmos. I'm just going to put a y equals x to the power of 2 graph on there. So there's my basic parabola on the screen already. And then I'm going to add a second equation. If I just click down on the number 2, or I can go plus and add equation there. I can add a y equals x to the power of 2 plus k. And Desmos is a nice word. It says add a slider for k. So I'm going to add a slider for k. So now I have a value here, k equals 1. So if I set that, so right now it's x squared plus 1 is what we have here. So this means the green graph is x squared plus 1. And I can slide that k value up and down. You can see what happens as I slide it up. It shifts the graph up and down. Notice the graph does not change size. If I line it up at 0, those two graphs line up nice and evenly. Okay. Also, note I can check any point on the graph. I can slide along here and say, okay, that's 2, 4, so what's the value at 2? I can use those to check on the graph and use that to find values. Just going to readjust this here so you can see that as I slide up and down. Okay, so there's my k value moving up and down, and again that graph does not change in shape, it just changes the position of it along the y-axis. Now let's change that up a little bit. I'm going to get rid of that, and I'm going to change this to h, or sorry, I'm going to change this to, in brackets, x minus h, and we'll add a slider for h. So there you see already we got -1. H is not positive, it's a negative here, right? It's -1 here, so x minus 1 shifts it over to the right by 1, and you can see that h value shifting that graph side to side as we move it. So again, the shape does not change, just the position of the graph. And now, if I get rid of that, I'm going to change this up again, and we'll take a look at ax squared. So we'll take a look at that a value, add a slider for a. So a is currently 1, thus the graphs are exactly the same. What happens if I put in a, and if I just click there, I can actually set a value for a as 0.5. Minimize that. There's a at 0.5. That green graph got wider. And I'm going to actually just change this here from, let's say, 0 to 1 with a step of 0.1. Okay, so that just means as I slide across there, it's going to go from 0, 0.1, 0.2, 0.3, 0.4, 0.5. That's what the step means. So we'll just stick to that nice small value there. So there's 1. And then again, as I make a smaller decimal or fraction, that graph gets wider. Note it's 0. Okay, that's why we say a cannot be 0. It's a straight line going right across. So a can't be 0, but it can be any other value to be a quadratic. And so you see the graph getting wider and wider and wider. I can, I'm not moving the vertex in this case. All right, so the a does not affect the vertex. H and k do affect the vertex. A does not affect the vertex. However, a does affect the shape of the graph. Now let's change this up, and let's go from 1 to 10. And we'll just step up by 1. So now we're getting positive values that are greater than 1. And so when we're at 1, again, there's our base graph. And now we have 2 times x squared, 3 times x squared, 4 times x squared, 5 times x squared. And you see the graph is getting narrower and narrower. It's stretching out, and each of those values is getting narrower so that the graph gets transformed in that manner. Now, if we want to switch this around, let's make this -10 to +10 with a step of 0.5. So, stretch my graph out. I'm back to 1. I'm less than 1 here. Try and drag it. There we go. Less than 1. Okay. 1/2. So it widens the graph. And then 0, not a parabola, but when I go to negative 0.5, I have a wider graph. Oop, try and zoom out here a bit. I got a wider graph, and it's flipped. If I switch that to 1, that's the exact same graph. A is negative 1. It just flips that graph. The vertex does not move in this case. It just flips the graph. So everything with the A is based on where the vertex is. And then I can get a skinnier graph. Again, negative 7 is the same as positive 7. So if I actually switch that manually, negative 7, positive 7. It's the same graph, same shape, just flipped around that point. Okay? So that's A, H, and K in their application. You can play around there and see how those work as well. Just for fun, let's combine them. And this is kind of going to prep us for the next section. A, H, and K. So if we start A at 1, and then we start H at 0 and K at 0, there we have our two graphs all lined up nice and even. So if we had an example like, add a third graph in here, y equals 2x x minus 3 to the power of 2 plus 4. There we have our shifted graph. I'm going to shift this over here. So there's our graph, our 2 x minus 3 plus 4. So I'm going to go through A, H, and K and show those adjustments on my green graph. I had to match up. Let's make this one, go to the edit here. Let's make this one blue. Okay. So we're going to match this green graph up to the blue graph. Right now the green graph is matched up with x squared. But let's start with the K, plus 4. So that means the graph, the vertex, and all the points shift up by 4. So let's slide that a little more, and boom, there we are. So their green graph now has the plus 4 added to it, x squared plus 4. And then minus 3. So H needs to go over to positive 3. So that it is a subtraction of 3 from there. Boom. And now our vertexes match up. So positive 3, positive 4, that's the new vertex. And then the K value is 2, so we just bump that up to 2. We stretch that graph out, right? We've taken that graph and we've stretched it out to 2, and boom, my blue graph now matches up with my green graph. So each of these is done step by step when you want to regraph. I would actually make 3 separate graphs if I was doing this manually on a piece of paper or something. I would do a light sketch of the K shift, and then shift that K graph over for the H shift, and then stretch that graph out for the A transformation. And that, playing around with that, you can kind of start to experiment and explore and see how A, H, and K all interact with the graph on here.